Okay, so for the partial sums approach, like we know it, we are going to build an extra array, which is called S, right? And Si actually means the sum of the first I elements, right? So I build it here. S1 is 5, obviously S2 is -1, 2, 6, and so on. Alright? So, how can we use this partial sums array? Well, as we know it, the sum of the subarray from left to right is going to be S right minus S left minus 1. Alright? And that's pretty obvious, because if you want the sum from 3 to 5, let's say, I'm going to take the sum of the first 5 elements and subtract from it, actually, the sum of the first 2 elements, because they are extra. So, I know this formula, S right minus S left minus 1. And now, knowing this, I want you to think real quick of a brute force approach with time complexity of big O of n squared using partial sums. Okay, I hope most of you got it, and it's pretty straightforward, because if we know that we can compute the sum of each subarray in constant time, in big O of 1 time complexity, we can definitely make 2 for loops, one fixing the left pointer and one fixing the right pointer, right? And for each left and right pair that we fix, we know the sum, and we're just going to update the answer if this sum is actually bigger than my current answer, right? Good. But if I want to solve this problem in big O of n in linear time, I can't actually fix both of the pointers, right? So I can only fix one of them. You can either choose to fix the left one or the right one. I just go with the right one, okay? So I'm gonna make a for loop fixing the right pointer. And let's take a quick example. Let's see, I'm gonna fix my right pointer here, okay? So here is my right pointer. Good. Now, when I fix this right pointer, at this step, I want to find out what is the maximum sum subarray, alright, of this subarray that actually ends in this right pointer, alright? So from all these subarrays, like from 1 to R, from 2 to R, from 3 to R, and so on, I want to find the maximum sum 1, right? The one that has the maximum sum. Okay, so how can I do that? Well, don't forget, I know this formula. So when I fix the right pointer, this S right sum actually becomes a constant. Okay? So this one is a constant. And now, the beautiful part. If this one is a constant, and I definitely want to maximize this sum, so this sum should be maximized. Definitely, for this sum to be as big as possible, the value that I subtract, alright, this value, S left minus 1, that I subtract from the constant should be as little as possible, right? So this should be minimum. So the only information that I need to know is for each right pointer, what is the minimum of those sums from 1 to right minus 1. Okay? Let's take a look at the example. If our solution was this subarray from 3 to 6, I'm going to have my right pointer here on 6. Okay? So I'm going to have 7 minus something. Alright? So I have to choose definitely the smallest something. And that is minus 1. 7 minus minus 1 is going to be 8. And if right is here and my left minus 1 obviously is here, the left is going to be here. And I chose this subarray from right to left. Okay? So the only thing I really need to know is for every right pointer, what is the minimum value of all the partial sums I have looped through by now. And how can I do that? Well, if I leave the right here, definitely I have looped through all these values. And I only need the minimum one. So I can make another variable and actually hold the information, okay, what is the minimum value that I've got by now? And eventually, if you want to know the position too, you can take another variable, its position, okay? So, it's very simple. When you loop through the right pointer, when you are at some right pointer, first things first, you update the solution. So you're going to have S right minus that mean, alright? So this is gonna hold in the variable min. This minimum that I now want is gonna be in my variable min. Let's call it min or min sum, something like this, min s. Okay? So I'm gonna update the answer with s right minus min s, and after that, for the next right pointers, I'm gonna have to update the min s with the minimum of the value it already holds and this s right, because this s right at the next step is also gonna be some s left minus 1 for the next right. Okay? So it's pretty simple. When you know the partial sums, you can fix only one pointer, and for this pointer you have to know the minimum value of all these sums that you already looked through. So just hold a variable for that. Now let's get to the code for this approach. Alright, so here we have again the function max sum subarray, which has two parameters, array a and its length, will return an integer, and like we said, first step is to build our partial sums array. So I just define my array s of length and max, like what is the maximum value that can length could actually take, and I initialized the answer variable with the first element of the array and the min s at first with 0, which is, notice that 0 is actually the s0 value, okay? Because like we said, we have there minus s left minus 1, so that s left minus 1 can actually be s0 too, okay? So I have here s1 equals a1, and then building the partial sums, si is going to be equal to si minus 1 plus ai, and then I'm gonna fix my right pointer, alright, with a variable I, let's say, and for each right pointer, which is I, I'm just gonna update the answer first. If si minus min s is greater than the answer becomes this expression, and after that, I'm just gonna update the min s variable for the next right pointers that are going to need it, okay? And then I'm just gonna update the min s variable for the next right pointers that are definitely going to need it. So if si is now smaller than min s, definitely min s is gonna become si, and in the end return answer. Alright? Your homework for this approach too is to actually think about the way of how can I return not only the maximum sum and also the subarray that has that sum, alright? So the left and the right pointer, okay? I can return it either here, but I should make a pair of int and another pair for the left and right pointers, or I can return it in the parameters of the function, alright? Just adding on two more parameters that are gonna be of type reference, okay? Because this type reference, actually, when we give a variable from int main, let's say, to this function, when you put the parameter here, actually, what value is gonna take inside the function is gonna hold and is going to be in the end even after the call in the int main. Okay, so these were the two approaches, the greedy one and the partial sums one. I really think they're both interesting and you understood it, guys. Don't forget to think about your homework, and as always, I can't wait to see you on the next lesson. Bye!